Okay, so here we go. We got some new stuff to show you. First of all, here is a version called New 5, which is actually newer than what I've uploaded. This program is designed to run under ROM 1.3, the graphical ROM. Skip most of that, but it tells you certain key information about that ROM and my program. And this is where you poke to 20811 in order to change screen modes. This is actually the buffer. This right here, I changed it to this instead of all those 96s. You just use this TASM command called fill 512, 96. It does 512 96s for you, and this gives you its address. When you load number sign this, it'll start at the very first part of this address. These are some patches, only one of them's implemented. This checks to see if basic is moved and performs the new or skips it if it's done. Start here. Clears, oh no, this is part of, this is what updates the screen mode. This gives you the letter address or font part. Let's see now. This adds an IRQ if needed. Well, I call them IRQs, or they're whatever you want to call them, but they're pretty handy because the computer, it's the closest thing we actually have to an IRQ in the MC10 besides the timer deal, which is pretty confusing. Okay, so this one engages when keyboard is pressed or when the keyboard is focused on. This one is for, that one didn't work so well. That one I was going to do for USR, but something funny happens with it, so probably take that out. And this one is to delete the gobbledygook on the high-res screen, and this loads the font address again. I don't know if it needs it again or not. I'll have to check it out. This is start 2, which is set to be IRQ, or set to return here all the time. And here is my new key pressed code, which is very short compared to the 3 pages of code it was before. So slowly optimized better than it was. It has a load X with a key mask, and key mask is down here. And this allows you to pull the keyboard to find out what key is pressed, send that information to the font, the system that places the font on the screen. This this calculates CSP, which is the current screen position, in 0 through 511. This decrements to the position before that. This puts that into the get location. This is normal PT patch, which is not a patch. Patch 0 is not a patch, or LDA 0. STA A PT 0 at PT means there's nothing. So we jump past. You might ask, how does it get here? It gets here through a patched ROM. Patched ROM jumps to a known address, which is right right here, jumps there, then it jumps to patch 1, goes down here, where did I go? Goes into patch 1, stores the current font, stores the current screen, or what I call the get location, which get location 2 to keep them separate. Push A, B, and X to remember those. Load the get location 2, generate another CSP, load number 1, store that number 1 at the patch, load current font, JSR past this stuff to here, and then it starts to calculate. This is a special little routine to save memory, so we don't need as much font, since they would just simply keep repeating themselves, since there's not a color to have all the fonts that we have in the regular screen mode that we're all used to. And plus you can actually program the fonts in this, eventually in this deal you could poke and the fonts would change while it's running. Skip subtraction, let's see, this calculates the correct position for where the font is, and this code will be shrunk down next someday. All of this all of this, or to here anyway, calculates where to place font parts. It's conditionally upon where it is on the screen, it'll calculate where it's going to put the next graphical stuff. This puts the graphical stuff. That just clears the variables to start over next time. This checks to see which patch is engaged. If patch 1 is engaged, it returns back up there and exits back to the ROM, which is in RAM. And then this patch 3 is not implemented. Or I mean 2 is not implemented, LMX3. Get out is working good. Yep, check 2 is working good. That's to make sure it scans the entire screen. It used to take like 40 seconds to get one scan. Now it takes about 10 to update the screen about every 10 seconds so far. Okay. Then when we leave, we pull A, B, and X. And here's some variables for the program. These are all variables. Here's some more variables. And here is the font. All the fonts. There's only 48 fonts. What am I saying? That's not what I mean. 48 graphical fonts, where are they? Let's see. Yeah, starting at 128, going down. Because they're logically repeating themselves, I can just... so they only go up to 175. And black and white screens would only need 16, but the color screen, since they have 3 colors, need 3 because the background color is 0 and the foreground colors would have to be the other choice, or the other choices. But let's see now. Okay, now that you've seen that, this this is room for some more variables later on to do other fancy things. Okay. Now I'm trying to think of what the best thing to show you is first. Is that I showed you the okay, so now I can show you how it compiles. You're right, TASM -68 for our particular microprocessor. X3 is the extension of the 6803. Did you know it had an extension? And extension instruction sets, or set. -B for binary. And then you take your text file, and I can show you how this easiest way to do this too is to there's several tricks. I think I showed it on one of the other videos, but you can write this down by looking up at the name up here. So if you don't remember the name, I usually go with a name that is easy to remember, like you know, new 001, new 002. The reason why I go 00 is because, and then a number, is because if I happen to have to program, hundreds of these, it'll still have plenty of room. So, and I'm actually past 100. I just changed the name. I think I've done probably 400 or 500 of these, but it's evolved. Okay, now I hit enter. It compiled. No errors. One thing about assembly is that it's very touchy, so it's always good to save a lot of new copies, because if you do a change and they save a new copy, so if I did a change, I'd go new 006.text, new 005.bin, and then compile it, and then that way when I run it, I'd be like, oh, what happened? I don't even know what happened. It broke. So that way you can keep it. You can always revert back to the previous one. Or you might want to try some radical changes, and you might learn more about the program and then go back to the previous one deliberately. A process of troubleshooting, Now, a trick about command prompt, and this is Windows 7, and I believe most of the Windows has this, where you push up and it writes the whole last line for you, and you hit enter. So this makes it very automated. Now, you can have Notepad open, command prompt open. You can have the MC10 emulator open, and they don't interfere with each other. Okay, so now the idea that I had to get this to work, for one, my program was completely in the wrong place in memory. I had to totally radically change the program, and I had to study the memory to see where am I going to move it, where's the most advantageous place to move it. Now, as you know, when you're in 4K mode, Radio Shack, Tandy, and their great wisdom decided to put a bunch of variables right on our screen, and worse than that, they actually made them so you can't move them around, and so very difficult to move them around. But anyway, long story short, there was not really short. Let's see. So when you expand the memory to the 20K, it extends it extends your ability to what? Let's see. Tired. Okay, so it expands when you load in the ROM 1.3, which is a graphical ROM that somebody wrote and changed all the addresses, so, and did some pretty fancy stuff actually. It's not identical to the original ROM, and I think there's a few things not even implemented, but for the most part you can't really tell the difference. So anyway, with that ROM is running, then all those variables and stuff, the guy who programmed it thought, well, I'll just move it past the screen, which was a really good choice, because what if somebody wants to use, he was at least knowledgeable enough to say, hey, someone might want to use all the screens, and he could have chosen to save a little memory by not using the highest risk screens that repeat themselves, but I actually found them to be kind of handy. You'll see if I run some programs later on. So anyway, if you he put it at 20479 is the very end of the screen. He put all those variables at 20480, I believe. Okay, so then after that, and it's about 300 and some bytes after that, which is basically exactly the start of my program, which is 20805. That's the start of basically where I put my program, is where basic would be. And then I move basic 3K ahead so I'd have room to program, which is this program right now is right around 2.5K. And I'd leave a little room for, for writing and changing size and all that stuff. And yeah, I'm glad to report that it actually went down from, it was up to 2,729. My first efficiency brought it down to 2,640. Eventually I got down to 2,550. So right now that's where it is, and I think I can shave off some more from there with that one part that I was telling you that I was going to change. Now we go in and I'll load, I'll show you how. See, to do this I realized I had to radically change my program to move, and I knew that would happen anyway, but in BASIC, without the ROM, it's really harder to do, to say the least. Anyway, unless you just leave those variables on the screen, then it's easier. So, my idea is that can I load the ROM 1.3, run it, and then load my stuff and run it. That's the way I did it for a long time, but eventually it quit working, and that was when I actually moved the screen from patching the ROM. And basically the ROM doesn't like not seeing my program there, so it wants my program there because it actually references it. So it'll crash if it doesn't see it. So I have to load them both actively to memory at the same time, and then I have to save both of them as a M file, a cload M file, in order to get them to just cload M them, and that's the file that's on MC10 Club. So now this is the way I first tried it, and I had patched a bunch of ROMs, and like only one of them out of like 10 worked the first time I did it. The first time I ran it, and I was like, whoa, it worked. I don't believe it. It worked. So that was pretty amazing. All the other ones, for some reason, were locking up, and so here we load our good patched ROM with the direct. Well, it's all patch stuff, but I mean, there's a specific patch that references memory. Well, it's gonna be faster. It's connected to backspacing right now, and that's not perfect either, but it's working fast anyway. So okay, now we'll load this, and we load it to address 0 because it's a copy of the whole 64K of the memory. So bam, we load it, and it loads that actively into memory. Then we load the next program. Notice I didn't change the address yet. That's okay. Okay, new 005 bin. Change the address now. 20805. We cannot set our execute address. Execute to 28125. And then now you won't see anything typed on the screen. That's natural, that's normal. It's actually actively running somewhere else. Execute, but my program is actually there. 20805, enter. Ta-da. Now, a couple problems. one is that little dot. That it doesn't say micro. It says, well, it doesn't say anything out there, but it's supposed to say micro color basic 1.3 copyright 1982 Microsoft. Okay, and then it shows our execute 20805. There's some adjustments on the fonts that I'm making. This particular version is more compatible. And if you watch this, I'll show you what I mean. Poke, and you gotta poke 20811, comma 36. Cool, huh? Now watch this. Sound 1, comma 1. Then poke 20811, comma 60. Sound 1, comma 1. And it doesn't matter which screen mode it's in. Doesn't care. Okay. Then poke 20811, comma which one did I do? I did 36. So we'll do 124. So there. And so we did 36, 60, 124. Running out of computer screen here. See how many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're on the 16th line. So 20811, comma, let's try 40. Okay. It scrolled up. CLS. Poke 20811, comma 44. There's another one. See some graphics. I just hit the break button, makes it flicker because it's always pulling the keyboard. So when it pulls the keyboard, it puts a value into 49151. It momentarily changes the screen mode. I was trying to figure out why it was doing that. Okay, so we're in number 44. Poke 20811, comma 100. Okay, there's that one. Poke 20811, comma 104. Okay, and poke 20811, comma 108. And that is the last one that is compatible, but guess how many modes that is? That's 8 modes that this thing's compatible with right now. And did you say, can it run anything? Did you just say that? So let's try something. Cload. And it's actually not clearing the screen yet, but I'm hoping someday to get that done. Cload, and I got a ROM 14A test. Open. List. You notice that the listing's faster than it used to be. Okay. Yep, I have a change in here that helps. Okay, this is pretty fast. I don't know if I want it this fast, but I had changed it earlier to go a little slower. I'll run it for like this for a minute, and then I'll stop it and maybe slow it down a little. Anyway, this is just an example of the sheer speed of being able to flip through. And there's a way that I made it pay more attention to the screen, which is it's a kind of a little trick you can do in your line programming. You can put a loop of, say, like some dummy variable, like for k equals 1 to 5 colon d dollars for dummy dollars equals key in keys colon next, and then what it'll do is it'll activate the interrupt to check the screen because of that keyboard interrupt that I used. And I might be calling it the wrong name, but I call it an interrupt, like I said. Pretty useful, and as you can see, it really likes to jump screens. And you can also make sounds while you're doing that. You can go burp, 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 and it does not change the screen modes. It doesn't care what mode it's in. It'll do sound while it's doing all those other modes, no problem. So I'm gonna CLS, then I'm gonna list 40. I'll give it time to catch up. 40 for SS. Got some font adjusting to do. Equals 0 to can't remember if it's 50. I think it's probably, let's try 25 colon a dollars dummy variable equals in keys dollars colon next. What you do is where you want the program to speed up, you'd stick a few of these in there, and it would print much faster to the screen for now until I get it sped up naturally. Okay, so I will run that, and that makes it so the screens don't switch as frequently. So I look at this and I say, you got about almost 5K. Probably when I'm done, you'll have 5K to program. What can you program with all these screens? Someone's got to be able to come up with something. Some kind of game enlightenment or something. Oh boy. But anyway, 5K, it's there. And okay, so now that I showed you that, and it may refuse to break on that too, because it's punching into the I don't know, it's accessing a lot of different things. Let's see, what do I want to do here? CLS. Okay, so that's kind of a big part of the update, but you see though, so there's 8 screens accessible. Also, you can also load this through cload M, as I pointed out on the club, and it's not here. This isn't even the right drive for that one. Let's see. Full screen project. I believe it's in the patch. Not there. Number 5. There it is. See, now what you gotta type here, actually since it loaded from a cload M, you can type execute here. Just execute, enter, and then execute 20805, enter, and then you type new, enter, because that's not fully implemented. For some reason it keeps phasing in and out of being able to execute a correct new. Don't ask me why, but I'll probably get that fixed eventually too. So print mem, that's your real mem for 4,679 bytes to play with. And this is a earlier version before I had the fonts fixed. So this is the 2-screen version, and then the same day I changed the fonts to where I realized that I could get 8 screens just by changing the fonts. And making compatible with 8 different screens at once, and then eventually my hope is to get it compatible with the other 8 screens. 1, 2, 3, 4, 5, 6, 7, I think it's 8. 4, so yeah, 8. And then there's 4 more screens, which are the regular screens. Those will actually be pretty easy to implement, but I haven't, they're not implemented yet. And basically how that'll work, you still have the same limited memory because you still have all this big huge program in there, but you could reference a regular screen, and all it would have to do is just scan the buffer and put it into the regular screen. So actually, in actuality, it'd be pretty easy. Actually easier than what I'm doing already. It'd be faster, 6 times faster, I believe. So anyway, that is the update for now. Until later, until next time, I'll see you later.